So another study, that is fluorescence studies, where you can look at the binding of this particular protein with the membrane, and one can find that this protein actually binds to the membrane. And what I will basically tell you that how this binding affects is affected by cholesterol and the pore formation induced by this particular protein. Okay. So maybe I will go straight with that because there is a lack of time. Another is to look at the pore formation is called the permeabilization assay. It's called calcium release. So there is a dye which can actually go inside you can load the dye inside this particular vesicles, and if it releases through the transmembrane pore, then you get the increase in the intensity. So the increase in the intensity basically tells you that there are some transmembrane pores. And when the membrane, you completely destroy the membrane, how you can use the Tritron X100 so that you can get the full release of the dye. And then you get the 100% release. So that basically give you the estimate, the percentage of release of the dye and indicating that there are some pores. Okay. So interesting part of this talk is this part, the phase contrast microscope. So if the particles are inside the particle aqueous solution, outside the aqueous solution, if there is no refractive index context, you will not get the contrast because it's too light, it's like a transparent. So what you do, you put sucrose inside the particle and outside the solution is glucose so that you make a contrast. And in phase contrast microscopy, what you get is halo region. Okay, so this is not very good picture. So it's a halo region. So the picture, maybe if I go back, this one. Full screen, make it full screen. It's very difficult. Here you can see this picture is very clear. And so when the pores are formed, what you try to get, so there is exchange of fluid from interior region to the exterior region. And due to exchange of fluid, you start seeing the loss of contrast. Okay, so loss of contrast, so that means it looks like a vesicle where there is no contrast between interior and exterior of the vesicle. So that basically suggests that there are some pores. Through the pores, the glucose molecule or sucrose molecules can exchange, and then you start seeing this. So this is the protocol or a methodology that actually we have suggested, and we also published this protocol. This is advantage is you don't introduce any fluorescence dye to look at it. So the fluorescence dye is an external molecule that can also perturb the membrane. So without doing anything, you will be able to look at the evidence of transmembrane pores. And so this is the effect of cholesterol. The moment you put cholesterol, you don't see the calcium release. So that means the pores are not there. And similarly, in cholesterol, when you add cholesterol, you start seeing there is no contrast loss. But this is contrast loss because there is no cholesterol, 0% cholesterol, and when there is cholesterol, there is no contrast loss. Okay? So that there is no pores inside the vesicles. So you use KMP11, and KMP11, when there is cholesterol in the membrane, you don't seem to see any kind of pores, transmembrane pores, so that you don't find any contrast lost in phase contrast image. Okay? So this is a hypothesis that we have proposed. So if there are pores, the parasite can enter into this through the transmembrane pores and survive inside the macrophage, you get infection. If there is no pores, if the cholesterol is more in the bilayer, which is expected because there are always you have 15 to 20% cholesterol in the membrane, and there is no pore. So this is a phase called very highly ordered, liquid ordered phase, cholesterol containing bilayer, and then you don't seem to see any pores, and there is no way the parasite can enter into the macrophage, and then you do not get the infection. Okay, so if the parasite cannot enter into this the macrophage, then that is another proposition of hypothesis, you can say, of leishmaniasis disease. Okay, so with this I would like to thank my collaborator. This is from IICB. So the protein I can get from Dr. Krishnananda, and the experiments I do it in my lab, all the model membrane study, and we are also doing some biological cell also. Okay, that is done by this lab, Krishnananda, and done by this particular student. He already got the PhD, and this particular student also, my student, they also already did PhD last year. And thank the funding agency DBT. Thank you for your kind attention.
Thank you so much, sir. Now I would like to invite questions from our listeners.
Physics, chemistry, maths,
Right.
everything is there.
So,
you can ask any.
I have a query, not question.
Okay, no problem.
So, what you have shown, there is micelle formed.
Micelles, it's not
Myceli.
micelles. Micelles are different from vesicles. So if you have a
But one head and one tail is there.
yes, in oil, water, if you mix this amphiphilic molecule, head and tail, okay. So if the head groups are bigger, the area of the head groups are, the cross-sectional area is bigger than the tail, then it is expected that the packing is in the form of micelle. So all the chains are inside, hiding the water, and the hydrophilic part, head groups are exposed to water. So it's a micelle. And vesicles are like it's a membrane, and because the edges of the bilayer are exposed to water, which is energetically costly, so it folded around and get the vesicle. So inside water, outside water, it's like a football, a bilayer sac.
Good. So, but now my one question. The question is, do you have any future aim to identify the porosity instead of the indirect supposition, that is contrast basis, by injecting fluid? And I think the fluid is same refractive index with the materials. Am I right? That's why it is not, contrast is not there.
Yeah, so you have a particle, right?
Yeah.
Big. And the thickness of the particle, that the football, the membrane thickness is 40 angstrom, which is much, much lower than the wavelength of light. So, it is lighter kache mone hobe transparent. It will just pass through, right? So, you will not get contrast. So, how will you see under microscope, conventional microscope? Because the resolution is, the wavelength of light is limited by wavelength of light. So, what you do, you introduce some phase difference. So, that is the basic idea of phase contrast microscopy. Quarter wave plate, pi lambda by 4, or pi by 2. Pi by 2 means lambda by 4.
Lambda by 4.
So, then you make a contrast. It's like a frequency modulation to amplitude modulation in electronics.
Yeah.
So, then you can look at the object like cells or some phase object, which is basically transparent in conventional microscopy.
That is correct. But is there
So
any
you do
indirect way to measure the porosity?
Porosity, no, you can actually do some cryo-TM, okay, TM, and then you can look at the surface of the membrane and you can measure the pores, or you can do the neutron diffraction. You replace the hydrogen by deuterium and you get the contrast, neutron diffraction, and then you can measure the pore size. People have done
Porosity
it.
distribution.
Huh?
Yeah. Thank you.
Porosity
Thank you very much.
Thank you so much, sir. Now we would like to thank Dr. Shanut Kormukar with a token of appreciation and a memento. For this, I would like to request Dr. R.N. Jana to hand over this token of appreciation and memento. Next, we have another eminent speaker with us. Mr. Pranab Das from School of Advanced Studies, VIT. I would like to request Mr. Pranab Das to kindly come forward with his presentation.
Good afternoon, everyone. My name is Purba Das. I am a research scholar under guidance of Dr. Shantanu Mandal sir, Associate Professor, VIT University, Amravati, India. Today, my topic is securing image and video for UAV devices. Actually, today we are using UAV devices for agriculture, defense, for several purposes. But we are using very much confidential information for transmission through UAV devices, but no dedicated image or video encryption techniques are not there. So in this research, we have developed one dedicated visual data encryption technique to encrypt those informations. Actually, UAV devices are working using battery power only. So if we use low battery power consumption some technique, that will be more useful for UAV devices. Okay. So there are many techniques for encryptions, but due to the randomness property, initial value sensitivity, but deterministic characteristics, chaotic systems are more suitable for this purpose. In 1963, the first chaotic system was developed by Edward Lorenz, and there also it has many other applications for just like pseudo random number generation, chaotic based communication, weak signal detection, and many more. So the objectives of this research is first developing one encryption technique for image, then extend these techniques for videos, and verification of these techniques using several analyses. So for this purpose, we have used one chaotic system which is earlier we have developed in reference to. Which is given in equation 2. The phase portrait for the parametric setup A is equal to 0.38, B is equal to 0.3, and C is equal to 0.57, and D is equal to 0.4 under the initial condition 0.8, 0.005, and 1.5 and 1. The phase portraits and the time series of these systems are given in figure 1 and 2 respectively. So this system has infinitely many equilibrium points. Also the sensitivity of the systems is can be observed here. Just a little bit change in the initial condition, the system is just goes to one fixed point to one attractor. The chaoticness of the system is verified here by Lyapunov experiment and bifurcation diagram. The hazy cloudy part of the diagram is represent the chaotic structure. The amplitude also can be controlled of the system by an external parameter, which is very much useful for engineering application for chaotic systems, which is described in figure 4 and 5. By amplitude control, the size of the attractor can be changed. Also, it can be swiftly shift in y directions also. The encryption techniques is in complex in nature, which is used here. The shuffling we have divided the image in a row wise and column wise manner in strip part, and then we use some combination using chaotic systems, which the shuffling row wise and column wise, and also rotation operation is here used, and also diffusion operation, which totally hide the image information. Here in figure 6, the linear image is encrypted and also decrypted. Here we have used one video for encryption technique. The encryption technique for image is extended to video encryption. First, this video actually taken from YouTube, DJI one source is there. So from there we have taken this video. The first original video is there, then we split into frames. In frames we divide into RGB pixel frames. Then we encrypt RGB. Then we combine that RGB and get the pictures RGB pictures for frames. Then we combine the sequence of frames, we get the encrypted video. Then we decrypt the encrypted video also. The several analysis has been performed. First, key sensitivity analysis. For key sensitivity analysis, just taking W0 is equal to 1 to W0 is equal to 1 plus 10 to the power minus 15, which is very small. The encrypted image is totally changed. The encrypted image for figure B is given the original encrypted image. For little bit perturbation in the key, the encrypted image is figure C. But figure B and figure C is totally different, which is analyzed by NPCR and USCI test. NPCR result is here 99.6% at least, and USCI is 33.5%, which is very much accurate. Also, differential attack is the encryption techniques can effectively resist the differential attack. The NPCR and USCI values for different frames is given here. For NPCR value is at least 99.61% and USCI value is 33.4% at least, and which is perfect for proper encryption technique. The histogram analysis also performed. For here it is shown for only for frame 1500. For the original frame, it is given in ABC for RGB channels, and the corresponding encrypted image, it is shown in DEF. For original image, we can see that several peaks are there, which gives some information about the image, but the encrypted image, which is totally uniform, so no information will be leaked from encrypted image. The analysis of adjacent pixel correlation is given here for frame 1500. For the original image, it is almost 1. So, it is totally correlated almost 1, but the encrypted image, it is almost 0. So, no information will be leakage in encrypted image. So, also visually it can be observed. For the original image, it is in diagonal form, but encrypted image, it is haphazard manner and just almost null correlated. The pixel intensity is also plotted here. For the pixel intensity, just pixel values, pixel positions plotted against the pixel values. So, pixel values here to defined positions different is shown figure ABC for RGB channels, and for the encrypted image, it is totally uniform. So, no separate pixel values is just rising up and lowering down. No fluctuation is there. It is totally uniform for the encrypted image. So, which is for RGB channels is given for in D, E and F for the frame number 1500. The main thing is there for whenever we are transmit some image data or video data, then some noises are coming. But if we encrypt some data, then noise coming, then we are decrypting from distant source. That is very much difficult, because if some noise comes or some data is almost cropped by some attacker, then after decrypting we may not get the original data. But here, if we crop the data 64%, 64 by 64 area, 128 by 128 area and 50% area of the image data, then also we can get the almost total image. The outline of the image after 50% data loss is remain same almost. Here are some references. Reference 3 here for the video which is taken from YouTube source. So, thank you.
Thank you so much. Now, I would like to invite questions.
I am fully novice on your area of work. I have one query. Can you go to slide number 8 and 11?
Yes, sir.
The picture, first picture,
yes,
from
sir.
first picture to last picture.
First picture is original image.
Okay.
Second picture is encrypted image using the algorithm is shown here in flowchart.
Yeah.
And third picture is decrypted image, which is also shown in reverse manner in the flowchart.
Yeah,
So
that's fine. That's fine. I understand. But what are the parameters you have changed here?
No,
that
no.
parameter should be shown so that one can understand.
Actually, we have taken this system for the encryption. The parameters all are for this presentation is same actually. This one.
All parameters are same.
No, no. Actually, these parameters are given here: A, B, C, D, and initial condition. Throughout all the presentation, we have keep it as it is actually.
And one question: why monochromatic color, RGB instead of, because picture is not only monochromatic; it is a mixture of colors.
Yes.
So did you try that?
Actually, RGB, 3 color channels are there. Each color channels has 0 to 255 depth. Each color in each color channel, each position 0 to 255 depth. So each color channels actually represent the monocolor actually, black and white image just like. So if we instead of using that RGB image, we are using also that monochrome, just black and white image, that is also same actually.
Okay, thank you.
So, in the beginning of your talk, that you have done some nonlinear dynamics,
yes,
that
yes.
I understand,
Yes.
this chaos bifurcation,
Yes,
and
yes.
how does it relate to your image processing? I mean, that parameter you were saying, no, A, B, C.
Yes.
So, what are those parameters which is related to the image
actually,
processing?
this is nonlinear system.
Nonlinear dynamics, that I understand.
Yes, sir. Actually, chaotic system has very random in nature actually. It is suitable for generation of pseudo-random numbers. It is most perfect way to generate pseudo-random numbers. Also, chaotic system is, if we give perfect initial value and parametric condition, then we can get some, after some iteration, we get some fixed value. But little bit perturbation, we get some another totally different position.
That is the characteristic of chaotic system. Change the initial value condition, you end up with the different position.
Yes.
Okay, so what I am saying is this nonlinear dynamic,
Yes.
how does it related to your image processing the work?
Actually, image.
I don't want to relate. I wanted to relate these
Oh,
two
okay.
things.
Actually, for image encryption techniques, we need some pseudo-random numbers. For just like a 0 to 255 range is there for each pixel values. So each pixel values we have to change somehow, so that image I have shown here some several peaks it is showing in histogram. Also pixel intensity, here pixel intensity is there. So I have to change somehow, so it will be in encrypted from uniform. So we can change just like a permuting the position of the pixel values. Also just including bits or 2 numbers. So for 2 reasons we need some pseudo-random number sequence.
Okay, it's just a random property of random number.
Yes, random property of that chaotic system.
Thank you so much. For this, we would like to hand over a token of appreciation to Mr. Parnab Das. For this, I would like to request Dr. R.N. Jana to kindly hand over this token of appreciation. Next, we have another speaker with us, Ms. Tonushri Das. So I'd like to request her to come forward with her presentation.
Good afternoon. I am Tonushri Das. Today I am going to present on the topic nickel ferrite RGO nanocomposite based sensor for highly selective formaldehyde detection at room temperature to monitor indoor air quality. This work has been conducted under the supervision of Dr. Mrinal Pal and Dr. Devdulal Saha, FMDD, Central Glass and Ceramic Research Institute. Metal oxide semiconductor metal oxide based chemirestive gas sensors are one of the most investigated areas among the gas sensing field, but over the past few decades the binary metal oxides like ZNO, TiO2 has been explored for their gas sensing properties, but those materials have few drawbacks like poor selectivity, high operating temperature, inability to detect lower concentration of gases. So the emerging gas sensing materials, we are exploring some of ferrites like nickel ferrite, some perovskite ferrites, also bismuth ferrite. So we have chosen nickel ferrite for its excellent stability, better selectivity compared to the other conventional binary metal oxides. Now the motivation of this work lies that semiconductor metal oxide based chemistry gas sensors can be useful for non-invasive health monitoring, detection of toxic gas leakage, personal exposure monitoring, indoor air and outdoor air quality monitoring, etc. And what are the advantages of these metal oxide semiconductor based gas sensors? These are very stable, highly efficient, very cost effective, and they are easy maintenance, and the topmost characteristic is that they can be developed as a portable device. So in this work I am discussing the monitoring of formaldehyde in air. So why do we need to monitor formaldehyde in air? We know that formaldehyde is a carcinogenic VOC, and it is commonly used in paints, adhesives, wooden furnitures. So when exposed to low concentration like 0.4 to 1 ppm, it can cause several breathing related problems, and these all symptoms as a whole can be called sick building syndrome. It can be seen in newly furnished buildings. So we know that higher ppm concentration exposure can be fatal also. In this work we are exploring the nickel ferrite RGO nanocomposite for its formaldehyde gas sensing property. Now the material has been prepared following the facile sol gel method, and necessary characterization was done by XRD and FTIR, confirming the composition, the formation of nanocomposite, and the morphology was checked by FSM and TEM, and we can see that this is the undoped material and this is the doped material. We can see that RGO sheets, and from the TEM also the graph RGO is visible, and this is the elemental edux of this doped sample. And from the tau plot has been employed to explore the band gap of the material, and it showed the decreasing trend, and BT surface area have also increased after doping. And the oxidation of states of the elements present in the sample was determined by XPS spectra analysis. This is the wide scan spectra of undoped sample, and this is the doped sample, and the peaks of Ni2p, Fe2p and O1s were detected, and it confirms the oxidation state of Ni is +2 and Fe is +3, and the latter will be discussed in following slides. Now after the preparation, we have prepared the sensor module following a slurry deposition technique and a Taguchi type sensor module, and the sensor module was checked for its IV characteristics showing the ohmic nature. Now this is the gas sensing measurement setup consisting of voltage source, which is needed for only if the sensor works in higher operating temperature, but for us this temperature is not needed because this sensor works in room temperature only, and there is a multimeter and a data logging computer. And this is the humidity control setup because there is a lot of humidity present in the room environment, so we need to check if the sensor works well in humid environment also. Now this is the sensing performance of our sensor. So we can see that compared to undoped sample, all the RGO doped sample has shown better sensitivity to formaldehyde, and this is the fitting of isotherm fitting of the all data shows that the best material is the RGO 1:100, and this is the dynamic response curve of the sensor when exposed to 0.5 ppm formaldehyde to 10 ppm formaldehyde, and this is the repeatability of the sensor showing the same ppm concentration, 5 ppm concentration, and the repeatability of the sensor is very good. And we can see that for 0.5 ppm HCHO, it has shown 31% N-type response, and for 10 ppm, it is 95%, which is, and it is room temperature. These characteristics are very good for device application. Now, the response and recovery time of this sensor is very fast, 1.9 second for response time and 23 second for recovery time. This is very good for excellent, I can say, for a room temperature sensor. And this is the long-term stability of the sensor was checked for almost more than 100 days, and it shows very almost no degradation in the sensing system. And this is the cross-sensing of the sensor was checked by exposing the sensor to various interfering gases present in environment, and we can see that it is highly selective towards formaldehyde. And the effect of humidity is also negligible, because at higher humidity percent also the sensor shows stable data. Now, the mechanism behind the gas sensing. We know that when the metal oxide is exposed to atmosphere, the atmospheric oxygen gets adsorbed on the surface of the material depending on the temperature of the surface. And when the material is exposed to our target analyte, that is HCHO, this HCHO molecule will react with these adsorbed oxygen on the surface and will create the electrons, and these electrons will go back to the system and decrease the resistance of the system. This is the basic sensing mechanism of the sensor. But what is the reason behind improved sensitivity of our sensor? We can explore that fact by deconvoluting the asymmetric O1s XPS peak of the undoped and doped sample. There are three components in this O1s peak. One is lattice oxygen, second is defect oxygen, and third is chemisorbed oxygen. We can see compared to undoped sample, the defect oxygen concentration increased from 38% to almost 60%, and chemisorbed oxygen has increased from 7% to 11%. These two oxygen species will act as adsorbing sites for the gas molecules, and these will, the more percent of OD and OC, the more sensitivity it will show. Now, for the selectivity, reason behind the selectivity, the bond dissociation energy of formaldehyde at this temperature is lower than any other gas molecules. That's why the material, for this material, the dissociation of formaldehyde will be easier. This is the reason behind enhanced selectivity of this material. This is the summary of my work, which shows that the RGO and nickel ferrite nanocomposite based formaldehyde sensor working at room temperature, which shows 95% N-type sensitivity to 10 ppm formaldehyde, and with a fast response recovery time and lower detection limit of 250 ppb formaldehyde. And these all characteristics make this sensor very promising candidate for a high performance room temperature device application. And I want to thank my guide and director CSIR for letting me do this work. Thank you.
Thank you. Thank you. Do you have any questions?
You have made a sensor for sensing formaldehyde.
Yes, sir.
Am I right?
Yes, sir.
So one of the slides you have shown there is a fish. So and
oh, fish. Those are the various application of the chemiresistive gas sensors.
I
that
understand.
can be,
I understand. Is it possible to quantify how much formaldehyde
yes,
is mixed
yes.
with the fish?
Yes, yes. We can detect it if we can calibrate a data sheet which with the data of the sensor, which shows that this is the response data for the corresponding ppm. If we take the sensor to the mixed gas and we get a value of sensitivity or response of that ppm, we can detect unknown ppm also.
Okay. Good work and excellent presentation. Thank you.
Thank you, sir.
Actually, in hygiene monitoring in this chemical plant, particularly, we have used such sensor. Okay. So that was partly projecting in the computers what is the limit, and accordingly we are taking some actions in chemical plants. So I think that will improve the
Yes, sir. Yes, sir.
condition also.
Yes, sir.
Okay?
Yes.
Thank you.
Thank you. Thank you, sir.
Thank you. We would like to thank you with giving you the certificate. Thank you. So moving on to our next presentation, we will welcome Professor Pulokesh Bera, Professor of Department of Chemistry, Panchkura Bonamali College.
Good afternoon to all. So my presentation material is coming. So I indeed really very pleased to be with you in this post-class session with my little work. So I am from Panchkura Bonamali College. It is an autonomous college. So I have one research lab, and I actually do some little research on anti-cancer study. Basically, I am a synthetic chemist in an inorganic background. So, due to time constraint, so I will not able to discuss all my research work here in details, but okay. The content, actually, what is cancer, sarcoma, statistics of cancer in worldwide, different treatment of cancers, chemotherapy, mainly I choose the chemotherapy, different type of therapy are there, and cancer drug, metal-based cancer drug, cisplatin, and selected target in anti-cancer drug design, cancer therapy using nanoparticles, a recent publication and notable pharmacophore. All these actually the common topic. Lastly, I will share with my work. So, what is sarcoma? What is cancer? So, cancer is now very interesting one research area because of its deadly some effects in our human life. So what is cancer? We all know that is abnormal growth of normal cells. Typically grow beyond their original boundary, and it easily invades the surrounding area and spread and also affected the surrounding cells, ultimate metastasis, that is the death. Effect of cancer, statistical view. You can see, there is the second one after cancer is fatal disease. Cancer related fatal disease, 10 millions. New cases of cancer, 20 millions, about, not the exact. So among this, lung cancer is highest, liver cancer followed by liver, followed by stomach, breast cancer. It is one statistical. So now countries, So many actually work are taken, projects are taken all over the world. So countries, those are engaged in some cancer research. I actually give the curve here. You see, USA, China, where is our India? You can see. Where is our position? India is here, but here is no indicator, pointer. So India, you see, the 1, 2, 3, 4, 5, 6, 7, 7th from the last. Okay, 7th from the last. So anyway, we are able to cast little about the cancer research. Okay. Then it's not moving. It's most frequent journal, so it is not very important. So you are you can see the most journal, the work was published in this journal generally. An organization with most published. Organization means lab. Actually, the part cell biology, the highest one. Biochemistry, molecular biology is also there. Biotechnology, applied microbiology is there. So all these are you see. So mostly cell biology department, they are doing the cancer research. Okay. So research area, most publication on cancer. I saw treatment types. So there are surgery, first stage, second stage, and third stage. So whatever the stage, according to the stage, the doctor will decide which type of therapy actually they will consider. Mainly you see chemotherapy, we focus on chemotherapy with drug. Okay, drug, that means a chemical compound. So chemotherapy, surgery, radiation, these are main three, well known to us. Radiation therapy, surgery, and chemotherapy. So our research actually on chemotherapy, what is actually chemotherapy? That is therapy by one chemical. So chemicals, all chemicals are not drug. So drug ability, or showing the drug ability, it will come when the molecule specifically target the cancer cell, and it binds with the DNA of the cancer cell, and it actually retarded or it actually diminished the cell growth or the proliferation effect. Then only we can tell that the compound is the property, drug-like property. Okay, otherwise we cannot call it drug. Okay, so we actually in our stop. Scrolling, not coming. So we actually design, okay, let it be fixed, no problem. So in our laboratory, we being a synthetic chemist, we actually design and synthesis, okay, okay, all these are. All these mechanisms. These are actually the published compounds which has some drugability. It is a drug. It can be used as drug. So these are all the compounds. You can see my compounds actually, if we see the title, that is thiazole, 5-member ring, 1, 2 heteroatom nitrogen and sulfur are there. Okay, and with this thiazole, you can see in each and every molecule, nitrogen, both sides of nitrogen are actually substituted. Okay, thus the drugability or the efficacy as a drug of the molecule, that depends upon the substituents. What kind of substituent we will add there, that is actually that will ensure the DNA binding property, and also the interaction, higher interaction ability with the DNA of the cancer cell. Okay, this is the main thing we actually. So we prepare lot of compounds here. You see, all these are prepared in my compound. So here you see the scheme for synthesis of complex, metal complex and ligand. All are thiazole base. These are little bit biological, some property we actually studied and concluded that this molecule has higher capability to become a good candidate for a cancer treatment. Okay, so these are all biological some experiment. So there are one after another experiment we have to do to check the property whether the compound has some apoptotic or a necrotic mechanism of cell death. So here we are able to synthesize, or we are able to synthesize some compound which is shown to be apoptotic nature, that is the program cell death. It will not disturb or damage the neighbor cell anyway. So in my new compounds, what we actually synthesize right now and nowadays, you see all the structure of the compound. We completed the characterization part. All the characterization part we completed. Here is one BM series. You see the first one, that is HPHTZ. It is one ligand, and the others are the metal complex. One thing I would like to mention here, that the metal we choose, not like platinum or rhodium or ruthenium, these are very heavy metal and had very toxic effect to the cell. So I here actually use the metals which are trace elements or essential trace elements, nickel, zinc, manganese, cobalt, like this. Okay, so these are all the candidates. And you see BM series, the compounds. Just give a look with this compound. Next BM3 series, you see the compound. Characterization part is completed. BM4, you see another series of compound. BM5, another series of compound. BM6, another series of compound. BM7, another series of compound. BM8, another series of compound. BN9, another series of compound. BN10, another series of compound. So with these compounds, so we have to complete all the biological work with these compound that I shown here. Now with some other previous compound, we published so many scientific some papers. You can see these are the recent published paper in my laboratory. Okay, this is my lab group. It's very big one. Lab members with his family, not only the lab members, with their family in some grand meet. So thank you for your kind patience. Okay.
Thank you. We would go for any questions.
Thank you, Dr. Vira. You are doing a great job because, we know that smoking causes cancer like that. But I am in chemical plant where we work with the market benzothioazole for rubber chemicals. There are so many carcinogen chemicals were there, and this research definitely will help us also.
Thank you, sir.
Okay.
Thank you. We would like to thank you with a memento and certificate by Sri Shamul Ranjan Maiti. Thank you. Moving on, we would be go to a tea break and we will be continuing with the online presentation. So our next presentation will be given by Rituparno Das. You can start. Thank you, Rituparna Das. Lovely presentation it was. Any questions?
Yes. So Rituparna, have you have used ResNet over here, right? ResNet 50. So have you tried any other model?
Yeah, I have tried TenseNet, but it was not that much good as the TenseNet's error rate is.
Okay. What about the accuracy about using this ResNet 50? How much accuracy it got?
I got around 100% as my dataset is not that much huge. So
Okay.
yeah,
Okay.
these are my probability values.
Okay. Okay. Thank you. What a good presentation.
Okay, sir.
Thank you, Rituparna Das, for your presentation. Now, moving on to our next presentation by Shanket Mehta, VIT AP University. You can start now.
Yes, sir. Am I audible?
Yes, yes.
Okay, sure.
Yes, start.
Is my screen visible?
Yes, yes, screen is visible.
throughout this research. And thank you so much for hearing me. Thank you.
Thank you, Shanket. It was lovely presentations. Any questions here?
Yes. So Sanket, according to you, what is the main cause of CO2 production in India, according to you?
Sir, main cause of CO2 emission, as we can see, India's population has increased in such a manner. Then people are using vehicles, people are using electricity. All these things require CO2. I mean, all these things are somehow contributing to CO2 emissions.
Okay. And did CO2 emission directly impacted COVID-19 and boosted it?
Sorry, sir. Sorry.
Did CO2 emission directly impacted COVID-19 and boosted it?
Uh, Maybe, sir. That's I'm not aware about, but I will
Okay, okay,
surely
no problem.
implement this in future
No problem,
researches.
no problem. So, and how is your model going to help our society?
Sir, as we know, LSTM models, we can forecast the future CO2 emission value, right? So when we are forecasting future values of CO2 emission, then we can implement this strategy. Like if we know that future CO2 emission is XYZ million ton, then government can implement some strategies to decrease that CO2 emission. Like if we know that future emission trend will be upper, then we can come to some sustainable solutions so that that upper level can be reduced, so that environment can be held, and our whole society can also be benefited from that.
Okay, Sangat. Thank you. It was a very good presentation.
Thank you so much, sir. Thank you.
Thank you, Shanket. Thank you, everyone, for attending our international conference on health, safety, and environment. This was the end of our first day of our conference. Thank you. You may leave the meeting now.